In this video, we look at the space physics questions, MCQs, their explanations. First is very easy for you. Second one, and statement 2 and 3 are correct. Why? Because light does not take that long and sun does not orbit Earth. So you read through the star formation and you will know that a white dwarf is not something that comes after explosion of red supergiant. Everything else is a possibility. Redshift definition, it is an increase in the observed wavelength of receding galaxies. So that is why it is called a redshift. So increase in the wavelength is redshift and increase in the frequency is blue shift. So if it is a redshift, it has always less frequency because of the increased wavelength and it is moving away from the Earth. If it is a blue shift, it will have a greater frequency and it is moving towards Earth. So here, redshift, so it is A, alpha. So you have to be very careful in your calculations. So this is the speed of the light. This is the journey. Orbital speed needs finding out. First, calculate the distance in meters. And then orbital speed will be the time for 1 year. So Earth's orbital period, sorry, not speed. Earth's orbital period will be time for one revolution. Number of days, hours in day, second in hours. This gives you this much seconds. And then distance divided time will give you this. Energy is nuclear reaction and it is due to fusion. So these are from the knowledge of star formation again, and you can read through the text. You will know that first of all, we have a gravitational collapse, and then we have gravitational attraction inward and outward, equalizing, expansion, and finally, before expansion, it is hydrogen converted into helium, and finally it expands. The correct statement is this one because here it should be radius. Moon does not orbit sun, and sun doesn't take light, doesn't take 5 minutes from sun. So orbit of Earth is elliptic. We should know this from the phrase MMJ sun. Here, the distance in meters of the galaxy, sorry, not the distance, the diameter of the galaxy is this. So what is this distance in meters? So first of all, 100,000 light years. Look at the calculation from the speed distance time formula. Speed is equal to distance over time. Distance is equal to speed multiplied time. Speed of light is this, and the time it takes to reach Earth. Sorry, the time in the time of 1 day is this much in seconds. So that's 1 year. Sorry, time of 1 year in seconds. So that's 1 year. The distance the light travels in 1 year. 100,000 light years means multiplied with 100,000 gives you this answer here. And this is a tricky question. First, you're asked to tell the duration of the Mars orbital duration. And the Mars is missing from the table, but we know that this is the planets in order. So the Mercury is the closest, and then Venus, and then Earth, and then Mars. Mars is missing. So we should know that the orbital period of Mars should be greater than Earth and less than Jupiter. So it should be a number between these two numbers, which is 690. That's why this is the choice. Again, simple distance time formula here. You're asked the speed, the orbital speed. We're given the radius and the time. So you divide the radius with time to get the orbital speed. Nuclear reaction is fusion in stable stars. So redshift of galaxy Y is smaller than that of, redshift of galaxy X is smaller than that of Y. So that means X is closer to Earth, very simple, and Y is moving faster. So it is IR and UV. These are the electromagnetic spectrums the sun radiates. Diameter of Milky Way galaxy is just keep this in mind for your knowledge. You might come across this question. So we have some relationships to understand. If we have mass higher, we have the gravitational field strength higher. So this is asked here that as the mass increases, the gravitational field strength also increases. You can see this for Jupiter, very higher than Earth mass, and its gravitational field strength is a lot more. Same is for Uranus. Just remember this, that the estimate age of Hubble's universe is done using, well, it's not this, this one. So which quantity is an estimate of the age of the universe? We use this to calculate this. So this is the formula for, it is this. Because this one is used to calculate the speed at which some galaxies going away or expanding. So this quantity is used as an estimate. The first is the cloud of gas and dust nebula. Redshift definition increase in the wavelength as it moves away. Object rotates around sun is planet that goes in elliptical orbit. And sun, from all these, this one is correct. Why? Because this is the only where fusion reaction and electron radiation is produced. Look at why A is wrong. Nuclear reactions do not produce radio and microwaves. Fission reaction do not take place in both. So we have two values. We have the distance and we have the speed. We have to calculate Hubble's constant. Formula is this. Just put the values. Remember this formula. It's not very hard. and put the values in this one. You will calculate h naught is speed divided distance. So you divide this speed with this distance, you will get the answer to be this one. And carefully look at this. This is second inverse. That's the unit of the Hubble's constant. We will come across this in next questions. So it's a tricky question. Radio signal is sent to Pluto, comes back. Distance is this much. What's the time taken? So if the distance is point this much, so it's going to go one way, covering this distance, covering this distance. So it's going to take round trip in this many light years. Milky Way is a galaxy and it has 100 billion stars. We know this from our knowledge. So what is PQR? R is definitely a star, E is a planet, and Q is a moon. Planet, moon, star. Sun is the biggest star. No, it is not. Sun emits UV, yes. Emits IR, yes. Helium is present, yes. So A is wrong. The Milky Way galaxy, it contains Sun and Earth. Forget the rest ones. Milky Way galaxy diameter, already done, 100,000 light years. Question about the weather. So we have a tilting towards Sun, tilting away from Sun, and in position 1, tilting towards the Sun. And this on the top is called northern hemisphere of Earth. So it will be towards the Sun, so it will have summer in the northern hemisphere due to its tilt towards the Sun. Whereas here, it will be winter in the northern hemisphere, is tilted away from the Sun, and at the southern hemisphere, it will be summer. So that's why we have different seasons at the two hemispheres of Earth. What is a light year? It is the distance traveled by light from Sun to Earth. It is not the time. Careful. The Earth is a planet, 365 days. What does this enable us to explain? The periodic nature of seasons. Why A, B, and D wrong? Well, it doesn't tell the day and night because day and night are due to Earth's own spinning, and the cycle of phases of moon, that's due to moons orbiting around Earth. Daily motion of sun has nothing to do with Earth's 365 days. So tricky question. We have the distance of the Venus from Sun is the radius and radius of Earth. So the shortest distance between Earth and Venus will be the difference in the diameters, and it's easy to calculate. 150 minus 110, and then using the speed will tell us that it will be, so the speed is equal to distance over time, and we are asked the distance, the time, so the time will replace speed, so it will be distance over time. Distance over time means this answer divided this should give us 130 seconds. Three radiations are microwave, light, and X-ray emitted by the sun. Hang on, what are the main radiations emitted by sun? IR, microwave, visible light, X-ray. No, it looks like this is wrong. So it should be IR, light, and UV. These are the main radiations. We get heat due to infrared, we get UV, but it doesn't reach us. There we have a ozone layer. We get the infrared and visible light. And these are the main radiations. Although sun do emit all the 7 radiation of the spectrum, but these are the main ones. And let's recall that um, the hotter an object is, the radiations it emits are different. So sun is not very, 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 very hot. It is very, very hot. That's why it is emitting mainly these radiations. Closest to the sun means it will have a maximum orbital speed. So its orbital distance will be small, will be taking the time to cover this at a maximum speed, and its energy will be minimum because of its distance from sun will be less. So powers the sun is the nuclear fusion. And this question is, although it might not appear in our exams, but it might, who knows? And we haven't done Hubble's constant calculations because they are not in our curriculum, but taking this opportunity, why not learn something? It is definitely at the next level, A levels. So this is the distance of the galaxy given, and we are asked to calculate the speed of the galaxy. And look at the notes. Carefully read the notes. This is done by using Hubble's constant used in astronomical calculations, and its value is 70 kilometers per second per megaparsec. Megaparsec, how would you read this? Megaparsec is a unit of distance used in astronomy. 1 parsec is 3 into 10 power 16 meters. That's a constant. And it's a unit of distance in astronomy. So 1 megaparsec multiply with mega 10 power 6 gives you 3 into 10 power 22 meters. Carefully remember this calculation and then go on. Now come to Hubble's constant and convert the Hubble's constant into, divide the 70 with this number and you should get this number as Hubble's constant. Carefully read its unit. It is 1 over second. Now come to the actual formula for speed calculation. Speed calculation of the galaxy will be done by V naught, V is equal to H naught times D. Hubble's constant multiplies the distance of the galaxy from Earth. Hubble's constant calculated here, substituted here, multiply distance given here, convert it into meters because above all calculation is in meters. We get this answer in meter per second, convert it into kilometers, and this is the answer closest to this one. So this is something you can explore, although it's not given in our curriculum, but just note that it is the brightness of the supernova in a galaxy that tells us how distant it is. We observe the radiation, the color, and we compare it. And the speed is the redshift. So we have the wavelength of the starlight that tells us the speed. Here.